were very excited to be supported by the Western Massachusetts Regional Unpaved Road Project, which provided the funding for the stream table engagement activities through the Executive Office of Energy and Environmental Affairs, their Municipal Vulnerability Preparedness Program.
I'm Madison from Makona High School. Berkshire Environmental ActionTeam with the Municipal Vulnerability Grant brought the stream table in for us to demonstrate real life inside of classroom. Our stream table is on a slant, but the meanders slows the stream down. Another thing we can demonstrate with the stream table is the deepest parts of the water, which are called thowags. The dye hangs out in the deepest parts of the water are the coolest, and a high fish population would mean that we have a high macroinvertebrate population. We went out and looked for them yesterday in a nearby river, and we saw some small ones and some bigger ones, and the bigger ones meant that they were just ready to hatch and turn into mayflies. They were in different stages of life. The little creatures, the macroinvertebrate, they like to eat debris in trees of vegetation that falls in, and that vegetation is called detritus. The detritus feeds the macroinvertebrates, and it is a part of the food chain that builds up to feed the fish.
All right, my name is Braden Melly. Here we have our stream table that we got from UMass, and I'm going to be talking about the headwaters. So the headwaters is pretty much the source of the stream. Around here, the Hinsdale Flats is the start of the Housatonic River. It starts as a swamp, and then it travels all the way down.
I'm Lucas. What I'm going to talk about is how the meanders slow down the speed of the water and create an equilibrium in the river. Meanders are the curves in the river because the water has to go around the curves, so it slows it down. The vegetation will help stop the water from eroding the bank and keep it from washing out throughout time. The roots will help hold the soil in place. From when the water splashes over the rocks, a lot of oxygen in the river helps keep fish and plants and other living things. Definitely helpful to learn about how the rivers form and shape themselves.
So my name's Don Marcella. Today I'm going to be talking about floodplains on the stream table. It starts with when the river's going downstream, and then there's a wider part with water that pools up. It allows it to flood, so in this area right here, you see that it'll flood. It has less speed, so it allows the vegetation to grow and then use the water for nutrients before it then goes back down the stream and tightens back up and goes down.
Hi, my name is Noah Willis, and I'm going to be talking about cut banks and point bars. So the cut bank right here, you can see it, sediment coming in. It's eroding off this bank right here, and all this right here and here is your deposition from it picking up speed and eroding off this bank and picking it up and depositing out to here. That I liked having the table there. It was easy to demonstrate really and see, and it definitely taught me more, 100%.
All right, I'm Carter.
I'm Olin.
Right here we have an example of a cut bank. So the water's moving at a faster rate with higher energy, taking sediment out from underneath, causing erosion. All right, when the water comes out faster, it can cause more erosion, leading to more meanders.
As sediment moves down the stream, it can stop in areas like right here and create a point bar. As it travels down, it's being deposited onto the point bar.
Yeah, I think it's cool that you can figure things out on this before trying it in real life. We had vegetation, and then we started getting into roads and man-made objects.
It gave a great example of what these certain things look like and helped us be able to see it in our heads more.
And my name is Eve Columbari, and this stream table was introduced into our classroom. So today I'm going to talk about what I learned about interflow. Interflow refers to the water that's flowing from the pores in the soil into the river. Interflow creates equilibrium in a river by constantly contributing water. So in times of drought, the reason that rivers don't dry up is because of interflow. I think it's really cool that we get to have a stream table because I've never done something like this before in high school. So I'm glad that I took this class and I was able to play around with it.
My name is Brady Preventure. I'm a senior at Wacona, and today I'm going to be talking about the delta. The delta is at the end of the river where the river meets a larger body of water, typically a lake or ocean. The delta is typically more slow than the rest of the river because it's pushing all that sediment down. Good example of the delta would be where the Housatonic River meets the Long Island Sound. The delta is slower. It meanders more. It pushes more sediment throughout its movement. So it won't be typically the same area. You'll see it, it'll go over here and then it'll change, maybe move over here. It's never in one area because of how much it's moving and pushing off all that sediment. Oh, this was great. This was so much fun. I learned so much about rivers. I learned all the different areas, how fast they can change, and what we do with construction movements and all that can really affect rivers.
The Western Massachusetts Regional Unpaved Road Project provided the funding for the stream table engagement activities through their Executive Office of Energy and Environmental Affairs, the Municipal Vulnerability Preparedness Program. Under this project, the Berkshire Regional Planning Commission, the Franklin Regional Council of Governments, and the Pioneer Valley Planning Commission collaborated to further develop the Franklin Regional Council of Governments Unpaved Road Stormwater Toolkit, which will help DPWs assess unpaved gravel roads and understand how to improve them to be more climate resilient. MVP grant awards support communities in identifying climate hazards, developing strategies to improve resilience, and implementing priority actions to adapt to climate change. The Town of Lanesborough, the lead applicant, was one of 71 projects to have received Action Grant funding for fiscal year 2025.